everyone, in this video, this is a number 3 problem. So aluminum reacts with hydrochloric acid to produce aluminum chloride and hydrogen gas. How many liters of hydrogen at STP are produced if aluminum reacts an hydrochloric solution which has a mass of 80 grams and contains 70% water? So first step is we need to balance the equation again. So number 3, aluminum reacts to hydrochloric acid. So aluminum reacts to hydrochloric acid. So we have right here aluminum plus hydrochloric acid reacts to aluminum chloride plus hydrogen gas. So this is not balanced yet. So you put a 3 coefficient here, and for aluminum is you put a 2 coefficient here. So you need to put a 2 here, and 2 times 3 which is 6, 3 times 2 which is 6, so 6 moles of hydrochloric acid. So we have a given here, we have 80 grams of acids. So we have 80 grams of acid. So mass of acid is equals 80 grams acid. And we have 70% of water. So we have 70% water contained. And we have the molecular mass of HCl, which is 36.5 grams per mole of HCl. So let's start to solve now. We need to find the volume of hydrogen gas. Okay. How many liters of hydrogen? The question is, how many liters of hydrogen? Okay, that's a question. So solution, we have 70% of water contained, meaning 100% minus 70% is equals to 30% of acid of HCl. So volume of hydrogen gas is equals to, we have 80 grams here of acid, so let's put 80 grams of acid here. So 80 grams of acid times the percent, so 30 grams of hydrochloric acid over 100 grams of acid, and then times the molecular weight or the molecular mass of itself, which is 36.5, divided by 36.5 grams of HCl, and then 1 mole of HCl, and then multiply the ratio. We have divided by the 6 molars of HCl here, so we have 6 molars of HCl, so 6 moles of HCl, and then moles of hydrogen gas, which is 3, so 3 moles of hydrogen gas, and then times the volume STP, which is 22.4 liters over 1 mole of hydrogen gas. And then you need to cancel the grams of acid and the grams of hydrochloric acid and the moles of hydrochloric acid, and then the moles of hydrogen gas, and the left is the liters of hydrogen gas. Okay, so the volume of hydrogen gas is equals to, so 80 divided by 80 times 30 divided by 100 times the molecular weight 1 divided by 36.5 times the ratio 3 divided by 6 times 22.4 is equals to 7.36 liters of hydrogen gas. Right? That's for number 3. And how about in problem number 4? We have a problem number 4 here. How many grams of ammonium sulfate must react with excess sodium hydroxide to produce 400 cubic centimeter of ammonia measured at 27 degrees Celsius and 98 kilopascal? So first step, we need to balance the equation again from ammonium to sodium hydroxide. So ammonium sulfate here reacts with excess sodium hydroxide. So to produce ammonia, so let's balance the equation again. This is number 4 problem. We have balance first the equation. We have ammonium sulfate. So ammonium sulfate here plus sodium hydroxide reacts to sodium sulfate plus ammonia plus water. So you need to balance the equation again. It is not perfectly balanced. So you put 2 water here and 2 ammonia here and then 2 sodium hydroxide here. So it's perfectly balanced. Okay? So this question is, when the temperature is decreased, the pressure increased and the volume will decrease. So the temperature ratio, which is T1 over T2, and the pressure ratio, which is P2 over P1. So that's the ratio. So we need to get the mass of ammonia. So we have a given temperature here and the pressure here, and the volume is given also. So put the temperature. So the temperature 1, which is at STP. So STP, temperature 1 is equals to 273 Kelvin, and the temperature 2, which is 27 degrees Celsius here. So 27 degrees Celsius plus 273 Kelvin. So equals to 300 Kelvin. And the pressure 1, which is 101.325 kilopascal. And the pressure 2 is equals to 98 kilopascal. So 98 kilopascal. And the volume here, the volume of ammonia here, the volume of ammonia here is 400 cubic centimeter. Okay, so equals to 400 cubic centimeter. So Let's start to solve again. We need to find the mass. So the mass of ammonia, ammonium sulfate, is equals to 400 cubic centimeter of ammonia times 22.4 liters of ammonia, so liters, and 1 mole of ammonia, and the ratio, which is how much the ratio in the reaction, which is 2, so 2, we write 2 moles of ammonia here times the 1 mole of ammonium sulfate, there's 1 mole here, right? And then the molecular weight of ammonia, which is 132 grams of ammonium sulfate over 1 mole of ammonium sulfate. Okay, and then times the ratio here, the ratio of temperature, which is T1 over T2. So T1 here is 273 and T2 is 300. So T1 over T2. So 273 Kelvin divided by 300 Kelvin times the pressure ratio. Here the pressure ratio is P2 over P1. So the P2 is 98 kilopascal over the standard pressure, which is 101.85 kilopascal. So you put 98 here, 98 kilopascal times divided by 101.325 kilopascal. So you need to cancel out the Kelvin, kilopascal, and the moles of ammonia and the moles of ammonium sulfate, and the grams were left, and there is a cubic centimeter here, so convert liters to cubic centimeter. So in 1 liter we have 1000 cubic centimeter. So cancel out the cubic centimeter here and then cancel out the liters. So the mass of ammonium sulfate is equals to, so 400 divided by 22.4 times 1/2 times 132 grams times 273 divided by 300 times 98 divided by 101.325 times 1 over 1000 is equals to 1.04 grams of ammonium sulfate. So that's your final answer. Alright. Okay, let's continue in number 5 problem.